And we're live with React 30. Hello, everyone. We're here to be chatting about React. My name is Kent C. Dodds. I'm your co-host. And with us today, also co-hosting, we have Michael Jackson. Say hi.
Hi.
And Ryan Florence. Say hello, Ryan.
Hello.
It's good for everybody to know who's who. And
You're
with
giving
us
Michael
today,
instructions, and so I figured I would wait for the instructions for me.
we do have a guest today. Sasha, why don't you say hi and introduce yourself?
Hey there, thanks for having me on. Yeah, my name's Sasha Aiken. I most recently was the CTO at Redfin and did a bunch of React stuff there, and I've been unaffiliated for maybe about a year or so, and I've been doing some hacking on React and other projects. And I'm delighted to be here.
I think the word is fun employed.
Fun employed is the word I often use, yeah.
Yes, that's exactly what you're doing. I love it.
Yeah.
So just for sake of our viewers, I mentioned in our last episode that I had kind of a short list of people that I wanted to get on this show, and Sasha is definitely one of the people on the short list. Sasha, I met Sasha probably, I don't know, maybe a year and a half ago when Ryan and I first started our training business. We were, kind of looking for places to do the training, and Sasha was really, really gracious and put us in touch with Redfin, which is where we actually did our very first San Francisco training. We did one up in Seattle as well. So that was awesome. And I also met Sasha at the first React Conf at Facebook, Facebook headquarters.
And I mean, I would say that Sasha's the reason we stumbled into our current business model, because I was trying to make horrible workshops at hotel lobbies, and you were trying to have us do it at an Airbnb and this awesome hangout thing.
Yeah, I was going to cook breakfast for everybody.
Yeah.
If you're still wanting to do that, I'll attend.
Yeah, they would just show up for the workshop, and I'd be there in an apron, flipping eggs and.
Yeah, we were actually talking about that. We're like, yeah, we could cook them all breakfast. Actually, maybe we should still do it that way. But
this is the first I've heard that I had any influence on the business model. I don't know where my cut is, but
Yeah. Your cut is coming on this show.
This is your cut right here.
Awesome.
You'll get some. It's the GitHub stars. How many GitHub stars does your project have right now?
Oh, I think it was. I know it's over 1,000. I actually don't know right now.
All right. Well, everything over 1,000, that's your cut.
There we go.
But no, thank you for that.
Of course.
The way that we worked that out with you has really helped us a lot. So thanks.
That's great.
So Sasha has actually been working on some really, really cool stuff. Most recently, I saw him give a talk at San Francisco React Meetup about a library that he wrote called React DOM Stream, which is exactly what it sounds. We'll hopefully get further into that today.
Yep.
And also a project called React Server, which I think is based on a lot of the work that he did as CTO at Redfin. So just to remind our viewers, React 30, the 30 in our name, is because we promise not to waste more than 30 minutes of your time, your precious time. So hopefully this will fit right in your commute. So let's jump right into it. So Sasha, tell us a little bit about kind of some of the problems that you faced at Redfin as a CTO, and looking at your architecture and your infrastructure, and some of the things you learned about serving websites quickly that kind of influenced some of the work you're doing today.
Yeah. So one of the big problems we had at Redfin was that a lot of our traffic came from SEO, and SEO. You technically don't have to render your page server side for SEO. Some people will tell you, but in our experience, it was pretty darn important. It was, especially a year or two ago, and I think it's still true even now. Googlebot says it does JavaScript, but sometimes does and sometimes doesn't, and it can be very undependable. It also just is a lot slower if you really depend on sometimes if you depend on the entire JavaScript to come down, get parsed, and then start generating DOM.
Sorry to cut you off. We've noticed that on our site, for example, we'll go and look at Google Analytics, and our site is completely. So we wait for some data to come in from Firebase, which obviously takes some time. There's some latency there. But anyway, Google takes a screenshot of our page, and all of that data is there. So
Yep.
it does seem to be kind of like a black art. Like, are they running JavaScript? Are they not? They obviously are.
So they absolutely are,
Yeah.
and they have been getting better. And my info on this is out of date, maybe by a year, let's say. But our experience, at least then, was that it wasn't necessarily that good, and it could break randomly without you really knowing it, unless you really every day were looking at every page in Google Web Master Tools, which if you have a few pages, maybe is possible, but if you have a really big site, was basically impossible.
Right, and
so
it's
like
also,
yeah, go ahead.
We should remember also that it's like Google's not the only search engine, and depending on your target market, you could be turning off a huge audience by not supporting other search engines as well.
Yep. And I think and the other thing is, even if you don't care about SEO, it's just faster to have HTML. Browsers are very fast at displaying HTML while they are parsing and starting to run the JavaScript. So anyway, but sort of somewhat long story shorter, we kept trying to figure out better ways to do server-side generation of a page that was very JavaScript heavy. The thing we used for a long time was pretty, had some issues. We were doing a lot of crazy running of JavaScript on the server in browsers and blah blah blah. But when React came along, I suddenly was like, oh, this is a really interesting front-end library. And I remember I saw a talk at F8 a couple years ago, and it was Pete Hunt when he was still at Facebook. And I went up to him afterwards, and I was like, "Hey, can this thing do any kind of server rendering? Because that's all we really cared about." And he was like, "Yeah, you just render it to a string." And I was like, "Ah." So we started playing with it. And while I was sort of towards the end of my time at CTO, and actually I stepped down as CTO, but stick around for another couple months to help work on the project that became React Server, which Redfin open sourced a couple weeks ago. And the basic idea, so Redfin does most of, once again, I haven't been there for a year. I keep in touch with folks, but my info's a little out of date. But as far as I know right now, basically all of their client-facing site is now server rendered in React. And they use React Server, I think, for all of that. So for the last year or so, as I've been off and fun employed, I've been playing with I've been working on two different projects. One is React Server, and the other is React DOM Stream. And they're both about server rendering and trying to sort of improve the performance and sort of work out some of the perf kinks.
Just going to say real quick, you can go to github/redfin/React Server to find that if you're listening.
Absolutely. Absolutely. I guess maybe I'll talk first about React DOM Stream because I think it's sort of the simpler of the two.
Yeah.
So React DOM Stream is a library. It's actually a fork of React that I wrote. So like 99% of the code is just straight up React. And all I did basically was added a way to, instead of rendering to a string, which is the way that React does server rendering, you give it a React element and call React DOM server dot render to string. It just renders to a node stream. Now, why would you want that? There's a couple reasons. One is render to string is actually often surprisingly heavyweight. It's doing a lot of stuff as it traverses the tree of elements. And it's doing a lot of stuff that it doesn't necessarily have to do for the server side. Partly because it's one code base, and it's doing a lot of the stuff that it would do on the client, like worrying about event handlers and all these things and worrying about setting up a virtual DOM tree that it can be mutated later on, that are just utterly not needed on the server.
Just don't need them. Yep.
Not at all, right? And so it pins the CPU for however long it runs. And then only at the end, once it's done, do you get the string of rendered HTML. Conversely, what this library does is it hands back a readable node stream. So it's basically just starts streaming out the markup, and as it traverses the element tree, it's outputting markup. So it starts outputting markup as soon as you call, almost immediately. So if you have a large page that takes 100 milliseconds to run to render, React DOM Stream can get you the first byte in 2 milliseconds, and the last byte will get in at like 100.
So do you find that there is? So I watched the talk that you gave at San Francisco React Meetup about this, and you were talking about using chunked encoding, basically.
Yep.
Which I think you said in that talk was something like, you said it's criminally underused, I think was the term you used. Right. Which I was like, thank you for bringing some attention. I mean, it's, you read about like things like Facebook Big Pipe, where where they just basically keep the connection open to the browser. Yep. I mean, for indefinitely, right? And they're just streaming stuff down, data and markup, sort of as needed. So, what have you found that there's like an optimal way to do the chunked encode? Like for example, what sizes are your chunks, or do you even care? Is it just like sort of as fast as we can render them, we can send them?
Yeah, so that's a good question. I don't have enough operational experience to know. Okay. I could talk to some of the folks at Redfin, and it does get complicated. Like, so just to give folks listening to the podcast who may not know background, chunked encoding is this way that HTTP servers can send down pieces of the page. You don't have to generate a whole page before you send it down, right? You can say, you can just send it down, 10 bytes at a time if you want. And browsers are actually really good at dealing with this. Browsers are phenomenally good, actually, at rendering partial pages as they come down, because browsers are used to pages being sort of streamed in off the network, even if they were sent from the server completely, in one piece. So chunked encoding, you can take advantage of this fact by sending the content from your server as soon as you get it, streaming it out as fast as you get it, and the browser will then display it as fast as possible. Now, there's some caveats there. One is, if the browser won't start rendering until all the CSS is loaded. So critical CSS might be good to inline. Another issue is that proxies in between the browser and the server can coalesce the information and sort of defeat streaming. And the last big one. I mean, most of them don't these days. It's been around for 20 years, but we had a certain CDN that like defeated our streaming for a while, and we had to spend
you're saying that
months. Months going back and forth.
But they don't know you can actually do this.
Right. We eventually got them to turn it on, but it just took a while. And the other thing is that there's one other thing I want to say. Oh, another pitfall people often find is that you often put a compression layer, which is really great, like usually gzip, and gzip needs a window of content before it can start compressing, right?
That makes sense. Yeah.
Yeah. Now, usually that's like 10K or 12K, so it doesn't defeat streaming. It just sort of makes the streaming a little bit chunkier.
Mm-hmm.
But to answer your question, Michael, I mean, I think in practical sense, what normally happens is you have a gzip layer that actually does no matter how small the chunks React DOM stream outputs, they're probably getting coalesced into bigger chunks by the compression.
Wait until it has enough bytes to do its zipping, and then it's going to send them.
Yeah, but it does still stream, just in a more chunky way.
Absolutely. So basically, by skipping, we can skip, the sort of virtual DOM representation. Obviously, there is no time on the server. This is, HTTP is stateless, so we can just make a request. We can skip that part. We can also skip doing things like setting up event handlers. And then we can also stream the server. So what kind of results are you seeing as a result of, just like, could I just swap in React DOM stream for React DOM in my app and pretty much kind of expect things to more or less work as they used to when I was doing render to string with React DOM?
More or less. So I would say, more or less. I mean, obviously, you're not outputting a string. You now have to pipe it to a stream. Yeah. But usually that's just a one-line change.
The drop-in replacement. That's awesome.
Yeah. I mean, it's not exactly drop-in because it's not a string, right? You have to do dot instead of dot write.
Exactly. Right. But you don't have to update your entire application throughout your code at all. That's awesome.
No, it's like one line usually. So I would tell people try it out because it's only one line you'll have to change back.
Totally.
Right. And test it out. I mean, I think in the tests, the benchmarks that I've run, the basically time to first byte stays constant. It's around a millisecond or two. And time to last byte increases as the page gets bigger and bigger, obviously. But generally right now it stays below what it would be with render to string.
That makes sense.
So
Yeah,
if it
just
was
by a
like,
little bit.
if it was like 100 milliseconds with render to string to get to the very last byte, which is also the very first byte,
Yes.
then we would now be getting our first byte in like 5 milliseconds, and we're getting our last byte at like 90 milliseconds. So we're still under
something like
the
that.
total,
Yeah,
and we're getting it immediately.
Yep,
That's awesome.
that's what I've been seeing. One caveat I will say is that I have not updated it for React 15, so it's still React 14 only, and that's because I have been trying to get it. It's a pretty major. It's like lots of brain surgery on React, and then React 15 came out, and I'm like, oh great, I'm gonna have to do this all again and copy all this stuff over. And so I started to talk with the React Core team about getting it as a feature of Core React.
I was gonna move to that next. So you've been doing all of this React DOM stream stuff in userland, but then I noticed you've also got some PRs open on React Core itself, where you're talking about. In your words, let's see. So this is PR number 6618 on Facebook React, where you're talking about pulling apart server DOM rendering from client DOM rendering to enable streaming right in Core. Could you tell us a little bit about that work?
Sure. Yeah. I mean, it's ongoing, and the discussions are ongoing, so things are subject to change. But basically, I'm trying to work with some of the folks on the Core team to get streaming into Core. And right now we're at a sort of a junction point where there's 2 or 3 different ways to go forward. I've actually got 2 active PRs right now, trying 2 different strategies. And I'm actually go ahead.
Ask a question before we get too far into about the implementation details of how to do it.
Yeah.
Does that mean that that the React team is maybe not excited about this, but like they're willing to do it? Like
they've been working with me. I mean, they've been really, really lovely. I think different people on the team have different, have different priorities, and so I don't think they necessarily speak with one voice on it. You know what I mean? Like, I think some of the team members are really excited, some are less, and I'm working with them to try and figure out what that means.
Cool, because Michael already brought up Big Pipe, and like.
Yep.
I mean, it's exactly Facebook's approach to make their website fast, right? It's like we got something, we're ready. Exactly, but same idea. Let's flush this, and let's keep this open and keep on sending stuff down as it comes, so we get a quicker perceived experience. Well, it's not just perceived; it is faster.
Yeah. I think the issue is that like Facebook themselves don't do React server side, right?
Yeah, exactly.
So
that's the issue. Like PigPipe and all that stuff is already written in PHP. They've already got the infrastructure for all that stuff. So like if this were to make it into Core, it doesn't mean they'd actually be using it.
Right.
It's just guys like you and I want to use it.
Right. But there are a lot of folks at Airbnb are interested in it, and they've been helping me out. And the React team, to be clear, like especially for a feature that doesn't actually help Facebook, have been incredibly helpful and useful and really great to work with. But it just it'll take a while.
Spike is also on my short list. We're going to get him in
Spike's
here to talk about some of this stuff as well.
Yeah.
He's the one who originally did the render library, I think, for doing Backbone views.
Oh, that's right. Yeah.
Side.
Yep.
So I kind of cut you off when you were about to talk about the two PRs you've got open.
Yeah. I mean, it's just there's 2 different PRs against the React Core, which are basically just 2 different strategies to go to integrate it in, because it is sort of complicated. It's complicated surgery on the code, because one thing that's not obvious until you really think about it is render to stream is asynchronous. Streams are always asynchronous, right? So it's changing this synchronous walk of the DOM tree into an asynchronous, like pausable walk of the DOM tree. And the question is like, how much code should it share with the more synchronous version, and what should that look like? And it's hectic.
I mean, do you even have so the key right now to render, server-side rendering with React is that checksum, right? So I can take a look at all of the HTML, I can compute the checksum, I can stick it in the topmost div, and now when the client-side JS lands, all I got to do is check the checksum, and then I know that, okay, I don't need to render anything. But it seems like with a stream, That checksum
Yes.
is not very useful, right? I can't use
It
this as a
is.
strategy.
It is. You can. It turns out. It took me a while. Yeah, it took me a while to figure this out, but this is a funky little implementation detail that I want to be clear. As a user of React DOM Stream, you do not have to know about it, but I'm kind of proud of it.
Yeah, totally. We're all about the down and dirty implementation details here.
So right.
You got to master the checksum before you can use this.
Yeah, right. I don't want to tell people that. So yeah, the server-side rendering does what's called an Adler32 or Adler32-ish checksum on the markup that it generates, and it puts it into an attribute in the top-level div. And React on the client side basically generates the string as well, and then does the checksum. And if the checksums match, it doesn't replace the DOM at all, which is really nice. It doesn't have to do anything after it's generated the virtual DOM. So what I did was, and so there's this problem that you're pointing out, that when you stream, you don't know what the checksum is going to be until you get to the end of the markup, and by that point you've already outputted the div, so you can't add it as an attribute to the top level div, right? Exactly. So what I do is I output a JavaScript, an inline JavaScript.
Hold on. I'm gonna have a drum roll before you say this. So what do you do?
It's not that exciting. So I output an inline JavaScript chunk that basically, so by the time I finish the markup, I know what the checksum is. So I read out the checksum into this JavaScript chunk, and the JavaScript chunk queries the DOM for the div above it, and sets the attribute. And then the JavaScript chunk deletes itself, because if the JavaScript script node is in the script node is in the DOM, it will throw off the checksum. So it deletes itself out of the DOM, and then everything's good.
That's
very good.
That's hysterical.
These sound effects here, but that's a pretty cool trick.
It is a trick, but it works, and I've tried it even in IE. Well, I don't know if I tried it in IE. I think I even did, even though React doesn't support it.
I'm sure it works in IE.
Yeah, right, of course. I should talk. We have a few more minutes. I should talk about React Server a little bit.
Yeah, totally. We have 7 minutes and 55 seconds. So yeah, let's talk about. So React Server is kind of one level above. React Server is like more like a framework type thing, right?
Yeah, it really is more like a framework. So it's the framework that Redfin uses for server-side generation, and it does a bunch of things that are mostly focused on performance. It's actually inspired by a lot of the sorts of ideas that BigPipe, Facebook's BigPipe uses, although it's just sort of associated in terms of ideas. A couple of the things it does is, let's see, what should I focus on? One, it focuses on some common problems you have when you're doing server rendering. One thing it does is it sort of intercepts all of your data calls and bundles those together and sends them down to the client in a script tag, so that when the React elements and your code runs again on the client, it'll get the same data, right? Like there's this problem, this constant problem with server rendering, that on your server you do some calls to your database, and then you send the markup down, and then on the client you might try and redo those same calls to the database, and things might have changed, and now your markup has changed, and everything kind of goes sideways. So you really have to make sure that your data calls get the same results on the server and the client. And React Server just handles that by basically sending down the results in a secret cache, and on the client side it serves those out of that local cache rather than going to the network. Does that make sense?
I have an analogy about this with babies and raisins, but Michael doesn't like it, so I'll just...
Oh, raisins. If you haven't heard Ryan's story about the raisins, you don't want to hear this.
So that's one thing it does. Another thing it does is you can actually, rather than mapping URLs to just components, it actually maps URLs to like a page class. And the page class can define sort of what its title is, what its CSS is. It can have extra CSS. It has those things that are at the page level. But it also can have multiple elements. So it's not just a URL to one element, it's a URL to multiple elements. And that lets React Server actually stream those elements out. Like it might be the case that you have a header up at the top of your page, which requires no data whatsoever, right? And then below that you maybe have, at Redfin we had a section that had the price, the beds, and the baths, let's say. and then below that you have maybe similar homes to this home. Redfin, we had pages about homes. Yeah, in React Server, you can have those be 3 separate root elements, each a React element. One is a header, one is the price beds bats, and one is the similar. And if the similar one depends on data that takes 200 milliseconds, it's fine. The header can be rendered and sent out to the network before you even get the data back for the stuff further down the page. Does that make sense?
Yeah, that makes
I was
sense.
gonna ask about that because I've been sort of leaning toward the case of why am I fetching the data on my server and leaving the user hanging with a white page after they click my link? I would rather send them my layout and then make an AJAX request and tell them I'm doing something instead of just a white page. So I was gonna ask you about that, but that's fantastic because now you can give them the stuff that matters and stream that down and then fetch the stuff on the server and then stream that down when it gets there. And so it's this perfect hybrid of it bends the trade-offs so well.
Absolutely. One of the trade-offs we kept having at Redfin, I felt like, was let's add another feature on the product details page, on the home details page. And when in a traditional server rendering context where you have to generate the entire page before you start sending the first byte, every feature you add to, doesn't matter if it's 10 screens down the page, it makes that first byte slower. And so a lot of the ideas in React Server are trying to solve that and change that trade-off. So you can add stuff further down the page and still get the top screen or 2 or 3 just as fast as you did before. Another thing that's actually really neat that it does, and I'm trying to see if I have enough time, we'll see if I have enough time to explain it, is it deals with misbehaving data endpoints.
Yes.
How much time do I have, Michael?
I'm not going to tell you.
Okay.
Are you going to do the
I'll try to go quick.
2 minutes?
Try to go quick.
It's more fun.
Let's say you have 10 data endpoints, JSON endpoints that your server does some requests to, and 9 of them come back really quick in 50 milliseconds, and you render and you can render the page. Now, but one of them is misbehaving. Something's going wrong with its database, and it's going to take a second. Well, usually what you would do is you would have to wait for that last one to come back before you send down the page, before you render the whole thing. The cool thing that React Server does is it has a timeout where it says, okay, after this time, I don't care if the data's gone, just send out what you have right now. So let's say that's set at 300 milliseconds. At that point, it will send everything, the entire page, but it will actually keep sorry, I'm not explaining this well. And then at that point on the client, usually what you do is you redo the AJAX request, right? I didn't get that one, we hit a timeout, I'm going to try and get that thing again. But operationally, that really sucks. Because what happens is, as a data endpoint, a database, or one of your services starts to go south, you double the traffic on it. Now suddenly you have one hit from the server, and then a hit from the client. Yeah. And that's just not a smart idea.
Sounds like
as
life.
Well, right, right. And let's say your server timeout was 300 milliseconds, and it's taking 500. If you go all the way to the client and then do another request, you've started the clock over again. It's going to take another 500 milliseconds. When we had that request in flight, so what we do is we keep the HTML connection open just like Facebook BigPipe would, and when we get the misbehaving one back at 1 second, we pipe it down to the HTML page in a script tag, and it resolves. And the client just thinks that it came from the network. So when the client does the request, we see, oh, hey, we have that one waiting on the server. We don't do anything. We don't send anything to the network, and we wait for it to be injected into the page dynamically. Does that make sense?
Yeah.
That's amazing.
Yeah, that makes.
That's super cool.
Right?
Yeah.
2 applauses. I love it. So that's really, really interesting. So it seems like React DOM stream
Applauses?
is
I think it's applausi.
I don't know. I think applauses is right. Don't correct my English unless you're sure, man.
No, I'm not correcting. There was a question. There was a big question.
Oh yeah, maybe. I don't know. This seems kind of like a low point in the conversation, so maybe this would be a time for us to run out of time. But so it seems like React Server is React DOM stream is let's stream the DOM. And then React Server actually does have a solution for, data fetching, like, which is something that, as the people who work on React Router, people are asking us about all the time. Oh gosh, how do I fetch data? All right, well, we have 5 seconds left. So
thank
Sasha,
you so much for letting me be on here.
Thank you so much, and we will see you guys next week here on React 30.
Bye.
Thanks.